So big news of today is that as we know, if we renamed it to panel content and say define panel count and just say n and just print n, make an attempt with that. I don't know what happens earlier. Oh, this just takes so long, I guess. Yeah. Around here is I'm looking at the number of zeros, and yeah, it goes I think all of the numbers are under 1 quintillion, and I just ask, yo, how, like this is one of those big numbers, like this is just kind of below quintillion. It's not just below, it's quite far below quintillion, but relatively it's quite below quintillion, and it says to just print every element until 1 quintillion. It takes 0.408 milliseconds per loop, and if you multiply that by this big number, you get those milliseconds, and that in turn means that you would need over here like 11,878.76 years to count to that high number. So iteration through all of that is not viable, not at all. Now the thing that got my attention is that we could is that there could be a solution of, like, we are constructing cubes kind of with this one, and we could make a formula for a cube, like how many panels do we need to construct a castle that's in shape of a cube, that's n times n times n. And I have never used that operation in Python before, but in Slovenia we call it korenjenje. So let's see how is that called. So korenjenje with 3 is 5. So if the cube is 5 times 5 times 5, then it's this. And we say English nth root. Okay, so it's nth root, just the power of x. So we say Python nth root. Check out how to find integer nth roots. Stack Overflow. So there is no built-in method, since kernel panic with some generic quote. Douglas Adams, isn't that guy who wrote like the Hitchhiker's Guide? No? Yeah, Hitchhiker's Guide. They say one solution. Oh, this asked to find the greatest integer less than or equal to the what? Happen to know that 5 cubed is 1 to 5. Background in this slip up cost me beating Google Code Jam. What is Google Code Jam? Let's see. Oh, okay. Oh, damn. One solution first bracket is the answer between low and high by repeatedly multiplying high by 2 until n is between low and high. Well, what we could do is to find the lowest number, is to say like something like, look, like the size of the cube. So we say define, and we say find size of cube, you know, because there can be more elements than just this cube, but we start off from the cube. So say define find size of cube, and we get an n. Solve that by saying size is 1, and we say while then if size is 1 and we start at 1, so we say while size times size times size is less than n, we say 1, 2, 3, 4, we say size plus equals 1, and at here we do we print out anything? Here we say print, and then we say just return size. So let's do that. Maybe that's still wishful thinking. Find size of cube with that pasted. Oh no. Well, that could also be a viable try, but copy and paste. So that is possible, and very quickly possible. So if you say 972,407 times 972,407 times 972,407, you get 948, and then it's 4, and then ours is 3. Alright. Okay, so now we kind of figured out an angle, because we can find the size of a cube, and then we just need to make a calculation for the size of panels. And then adjust it. Init. Right. Which Newton's method, which works perfectly well on integers, KNS. So if this computes a cube, we want to get a smaller one. So while size is less, and okay. Okay. Alright, so let's figure out the formula to the cube. We can use our little algorithm over here. If you comment this thing out. Shit, I didn't mean to delete it, I just meant to comment. Oh shit, I didn't mean to delete it, I just meant to comment it out. And use this panel count. My gen. Don't want to use that. Oh, my generator function. This is all panel count. So we say, oh, we must change directory. So we say cd documents programmering and then cd python sandbox, and then we say python 3. Then we say from app import. What is this? Panel count, and then say panel count for just one. Oh, and we also wanna remove print statements. All right, are now all of the print statements. Ah, okay, quit python 3. Fuck off. Not quit, that 6. Okay, 6. So panel count, there's 4, which is 2 times 2. So we say here 2 times 2. Wow, we need 20 of them. 20. Is that true? 1, 2, 3, 4, 5, 6, 7. So it's 4 times 4. And then in the middle 4. So what about the word 2 times 2? What about 3 times 3? That's 9. 9 times just a sec. Alright, so we do 3 times 3. It's 9. Oh, it's actually 3 times 3 times 3. Shit, and the same as before. So that cube is 9 times 3. It's 27. 108. Alright. And then, oh, so 27 cubes need 108 plates. And what about for 4 times 4 times 4, which is 64, if I'm not mistaken. Let's see. 4 times 4 times 4. Yeah, 64. 240. Panels. Now what about for that one? Oh, for that one. Oh, of course. Impossible. Oh, this is not 4 times 4 times 4, by the way. For certainly not. So yeah, how do we find that out? You know? Because we could say, oh, it is the so where is the this is how the post coding comments. This is Sketchpad. We go to Sketchpad. Cancel. New one. And if we say, if we just say the there is n times n thing, there's say n times n, and then here is also n. Over here we say that there are 1, 2, 3, 4, 5, 6 sides of n times n plates. So we say n times n times 6. That's called ploščina or surface. So that's called surface then. That's how you get surface. I'm kind of wasting time with writing here. That's surface. So there are also then there are insides. So how do you calculate the insides of that cube? I'm trying in my mind to create some kind of model. Which could help us. And okay, I got a mental model. So basically inside everyone we got a kind of a grid, you know. If we just cut this in half, what we see is zoom, 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 zoom. So that's a grid of bottom to top or top to bottom, and you get that. So if there are n, so for example if there are n is 1, 2, 3, 4, 5 cubes, then there are 1, 2, 3, 4 of those things in between, you know, those like plates, or so there's 1, 2, 3, 4, 5, and there's 1, 2, 3, 4. So then we say that's 5, that's 4. So then we say n times n minus 1 is the number of floors that times that times n times n times n. So then you say that is for all horizontal floors. I'm gonna use camel case. Floors. And the same thing for vertical floors. And that should be it. So let us pick an arbitrarily large thing. If we say, I don't know, 25 times 20, 25 times 25 times 25 times 25 is that. Copy, say 25, 25, 25. So that is the cube with n is 25, and that is the number of panels that we need. So we see if oh, just for the test, I want to see if both give us the same return. So we say per panel count with this one. Why? Ana LC o unuta. Oh, because we need to import it from app import panel count. Okay, so that is kind of broken. Alright, so we will still have that one. So we say 25 times 25 times 6 plus 25 minus 1 times 25 times 25 plus 25 minus 1 times 25 times 25, and that is then completely different number. Okay, fuck. Alright, so let us repair this thing. Say panel count. Oh, yeah, I get it. So this thing should be now. Okay. Let's say quit. There we go. We change this to just panel count, and that to panel count. Say Python 3. From that import panel count. Say oops. For 8750, 48750, and this is 33750. Okay, so I guess I missed something in this quick guess. Anthem 6 service. 1 2 3 4 5 1 2 3 4 times 4 n minus 1 times n. You got all the horizontal floors. Do that again. What am I missing? In this cube, in this cubicle. Boom. Okay, let's just test this algorithm for 4. So it says, no, 2 times 2. So 2 times 2 is 4 times 6. So we all know, like, say just like how many rooms are in 2 times 2, 4 is 20 of them. So say 2 times 2 is 4 times 6 is 4 times 6 is 24. Alright, and with this 24 we're already over the 20 mark. So apparently, alright, so that's 24 plus yeah, for real. 2 times 2 times 2. Wait, hold on. When we say 1, 2, 3, 4 times 6 is 24. That's 24. Okay, that's 24. So this algorithm is like wrong, I guess. Okay. How did I manage to get to such a bamboozle? Like 4 rooms. Sketch that out in my paper over here. Got 4 rooms. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, 2 times 2 times 2 is 8. Oh, okay. Fuck. 36. So it's okay. So that is 24. Shit. 24 plus 2 times of we say 1 times 2 times 2. So we say 2 times 4. That's 8. Is 32, am I right? 3, 2. Alright, so that says 36. Alright, and here's only 32. Alright. That's a manageable chunk. So 24, we know where it comes from. That takes us 36. So 32, we already know where it comes from. No, 24 we know where it comes from. It comes from the surface. So for the inside we have floors. 1, 2, 3, 4 plus 1, 2, 3, 4. Oh, but we're not counting the third dimension. Hold up. Cause we got like, oh shit, cause we got like this dimension, check, and if we draw that over here is check, kaboom. Maybe is there like a line drawing too? Line, yeah, alright, line. 1, 2, 3, and then fourth over here. So that's a line. Oh, stop it. Pen. Okay. Pencil is better. And we also need those ones. Alright, so we say high vertical and depth flooring. So we say just that times 3. Alright, so let us test that out. So we say 25 times 25 times 6, that surface, plus 3 times, and then I say 25 minus 1 times 25 times 25. Int object is not callable. Oh, say 3 times 48750, and then 48750. All right, nice one. Nice one. Why like I feel so stupid, you know, when I'm solving this. It feels really discouraging sometimes. Okay. 48750. So we have a great formula for cubes. We should congratulate ourselves. Congratulations ourselves. So here we say define number of panels in cube n. With n, and just say return this, where we say so first surface n times 6 plus all of the other ones. So it says 3 times n minus 1 times n times n. So that is just number of panels in a cube n. And from then on, we need to count the leftover panels, which are somewhere between like, which is unfinished cube. So you could say panels is at how do we modify this function to be able to count a number of panels from a cube with the size of an n? Just say string of panels. We can cancel out this starter thingy. Changes, we do not need. Yeah, do we need changes? What are changes? Oh, that's just for printing purposes. String of panels, that's also for the printing purposes. Next line elements, we need that. Number of lines, we need that. Number of skipped fours, we also need that. Let's say for step in range n, okay. Oh, and there's like some kind of number of lines back there. Wow, yeah, this is a confusing code, of course. Now, is there like another way? like to point an example, I mean to illustrate an example. Let's say, yeah, we get like a new blank one, and we say, yeah, we have a cube that looks something like this. Like so, like so, like so. To come. Oh damn. Fuck. Okay. Yeah, got bamboozled. Chuk, pakum, 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 pakum. It is impossible to draw. I think I should start like with something easier. Just say like, yeah, but I have to draw. Yeah, let's draw 2 times 2 times 2 cube. So it's 2 times 2 times 2. Alright, 1, 2, 1, 2, 1, 2, and we say that there is one more cube on top of here. Kaboosh. Yeah, and we get to see. Oh, look at that! It's +5. We know from before. Excuse me, I just need to stretch a little. Okay, I'm back. So what shall we do? You know, because from cube n times n times n to get to the cube with the size of n plus, so if n plus 1 equals m, so m plus 1 so that should be O then. O right here. To get to the cube with the size of O times O times O, we need to get square with size n times n, and then size with n times O, just say O, and then another one with O times O. That one looks like a cute face of a bear. So maybe we should check which, if there are any of the squares full. So we say our castle is at least n times n times n things long. I mean big. And how do we get that? This is an algorithm over here. Find size of cube n, and it says while that is less than n. That is the size, and if size times size times size is less than n, you say size plus equals 1. Then we return size. So you just return size and then -1. You should just return size -1. So here we could say, yeah, over here, number of panels in cube n, and also define size of the biggest cube if we get inside X. we say size, we start at 1 and then say while size times size times size is less than is less than x, of course, size plus equals 1, and after that we just say return size minus 1. That's the size of the biggest cube, because right here say find size of cube. That's, and then we get 9.9484. Here we got 4. So here we got one bigger, then we shall get one smaller. Alright. So what are we doing? Now we say first get the biggest cube and its panels. Number 2, check in which stage, or fill up stages, or just like check in which stage. Yeah, let's do that. Check in which stage, and stages are n times n, still with big numbers, n times n, n plus 1 times n, n, or n plus 1 times n plus 1. In which stage is the rest of the castle. 3. Add the panels from the full stages for calculate and add the panels from the so-called unfinished stage. Return number panels. Okay, that should work, I think. Okay, this we have. So let us tackle this thing. Check in which stage is the rest of the castle. Na zdrowie. Size of the biggest cube. Okay. Here we say n times n. Alright, I think it's time to delete that code. Yeah, we got panel count. So we say size of the biggest cube. Cube x is size of the biggest cube, and we input n. Of course, all of that must be above might. Alright, so the biggest cube, and after that we share the say so that's the biggest cube, and I think over here we can say panels. So that size. So let's say rooms left to construct is cube x times cube x times cube x n minus cube x times cube x times cube x. And those are rooms left to construct. And then we say if rooms we say if rooms left to construct, so we mark like this thing over here, n times n. If rooms left to construct is is that minus cube x times cube x times if rooms left to construct minus cube x is so that cube x plus cube x minus cube x minus 1, no, plus 1. Okay. Cube x plus 1. Like so, times cube x cube x. So then we know this is in this phase. So then we know, and if that is larger than 0, then we know that that is the last phase. So elif, and I wish I could just rooms left to construct minus cube x times cube x if that is larger than 0, the middle phase. So here the last phase is that we are left in n plus 1 times n plus 1. The middle phase is n plus 1 times n, and else we are in the first phase, which is n times n. Let us make another helper method, or just panels used. Well, that was a majestic burp. I shall finish the video here and continue immediately. I just don't want to be video long, like longer much more than 1